Terraform says configuration is valid. Pipeline is green. Pull request looks good. But there is a big problem. Terraform does not know your company's policies. Also, Terraform does not know production SSH should never be open to the internet. One more big problem is public storage access can expose customer data. These are very few things which I am trying to write down here, and this is exactly how small infra mistakes become real production incidents. So, in this video, we are going to build an AI Terraform Reviewer. Not a chatbot, not a magic AI tool, a simple practical workflow that scans Terraform code, finds policy violations, use AI to explain the risk, and generate a pull request style review report. By the end of this video, you will learn how to scan Terraform code before deployment, how to create simple policy checks, how to detect risky infrastructure patterns, how to calculate a compliance score, how to use local AI with Ollama and Mistral, how to generate a Terraform review report, and finally, how to keep humans in control of production decisions. If you are new to my channel, like this video, subscribe, and comment Terraform Reviewer. Based on the comments, I am going to open source this full repository. Let's build it from scratch. Now let's try to understand the architecture. The workflow is very simple, as I said. First, we have Terraform code, followed by we have a policy scanner. Then we will have the findings. Once we have the findings, we are going to do a AI review. We are going to bring AI in the workflow. Then we have a final report. In the end, human validation. This is a mandatory step. So this is how our architecture looks like. We are going to scan some Terraform's code using a policy scanner. Once we get the output with findings, we are going to use AI to review that, and also we are going to generate a final report. Finally, human will look at the code and try to fix if there are any things to fix. Now let's look at the project structure. We have a Terraform folder with some bad code and some good code. Then we have some policies folder, we have reports folder, and we have three important files. One is AI Terraform Reviewer.py, final report.py, and Terraform policy scanner.py. So this is how our architecture looks like. And now let's look at the bad code first. So for example, here I can see a resource group being created using Terraform main.tf file. Followed by we have Azure network security group here. And if you look here, source address is 0.0.0/0. Destination is, let's say, star. Followed by we have security rules, allow RDP from internet. And then we have some logs which are being stored in a storage account. And here if you see, allow public access equal to true. Followed by we have MySQL server administrator login and password details are hard coded, and also we have some firewall rules. So this is how our bad code looks like. Now I'm going to show you some policies which we wrote for this particular project. We can add more and more policies according to the requirements, but for this video I am keeping it a bit simple. If you look here, we have one of our policy rules.json file. Here I can see a policy name, severity, and the pattern, regex pattern we are using here, business risk, and recommendation. Then we have again no public RDP name, critical, severity, pattern, business risk, recommendation. So we are trying to follow a pattern here. So these are all the policies which we have in place. Now let's try to run our Terraform policy scanner. This particular scanner will try to read the Terraform file in this particular folder, and it will try to generate findings like this. We can see some findings 6, and also we can see some compliance score, deployment decision, block deployment I can see, and also I can see that reports are being written to this particular folder policy underscore findings.md. Now let's look at the policy findings.md file. So if I scroll down here, if you see scanned file I can see, and also I can see the total findings, compliance score, and also deployment decision. Findings by severity, critical 4, high 1, medium 1. Below we can see the detailed findings. Critical, no public SSH. This is, let's say, coming from our policies which we defined. For example, if you see line 26, business risk, public SSH increases attack surface and may allow unauthorized access attempts. Recommendation: restrict SSH to a bastion host, VPN range, or private CIDR. Now, also it try to give us the details, exact match Terraform. For example, destination port range and also source address prefix. We have to go there to this particular file and change this. The same goes with no public RDP. Terraform badmain.tf line 38. It is mentioning the line as well. So let me go back real quick here. If you look here, line 38. So it is talking about this particular port in this finding. Restrict RDP to private admin networks or remove it. Followed by, we can see no hard-coded passwords or secrets. So hard-coded passwords may leak through source control, logs, or CI/CD output. Use key vault. I mean, look here, it is telling us use key vault, environment variables, or a secure secret manager. So we have a clear findings of what all problems we have. Now let's quickly understand what exactly our policy scanner.py file is doing. So again, this is very simple file. If you are following this particular series, you already know what exactly we are trying to follow a pattern across all the projects which we are building. Here we have a policy file, policy rules.json. This is the file which we are defined in the beginning. Reports directory, findings, and findings MD. Followed by, we have some severity score, critical 100, high 70, medium, and low. Then we are trying to load the policies here. Followed by, we are trying to define the line numbers as well. Then we are trying to scan the file. So if you see, we are using scan file, and followed by, look here, we have policy ID, policy name, severity, file, all of this, business risk, recommendation, risk score. So if you have any specific thing that you want in your report, then you can add it here. That's so very simple. Now once we have that, we are going to define the compliance score and deployment decision as well, according to the severity. If it is, let's say, critical, block deployment severity is high, review required. And if it is low, I mean, we can ignore that. I mean, it completely depends. So for this, video, I'm keeping it simple so that it is understandable. Now, finally, we are trying to write all the reports into the reports folder. So this is what our Terraform policy underscore scanner.py file looks like. Now, let's look at our models. So we are using the local models as usual. So for example, I'm going to run Ollama space list, and if you see over all the projects which we have done so far, I'm using Mistral latest once again. So I'm going to say Python 3 space AI Terraform Reviewer.py. So we are going to send the scanner findings to AI. So I'm going to explain in detail this particular file as well, but let's look at the output now. If you see sending policy findings to local AI model. So blindly we are not sending all the Terraform code. We are trying to scan using our Terraform policy scanner, and then we are trying to send that particular report to the local AI model. This AI receives the policy findings and explain them like a senior DevSecOps engineer. This also reduces hallucination and also give us the better output. Now let's look at the review report. So AI Terraform Review.md. So if you look here, it clearly gives us the executive summary. Terraform policy scan of Terraform bad main.tf has revealed several critical high and medium severity issues that pose significant risk to the security and compliance of your infrastructure. The most pressing concerns are the absence of firewall rules as for SSH, RDP, SQL, and storage blobs open to public access. And also, let's say here we got an overview. I don't need to read the full document, but overall we got an idea what exactly is this particular file talking about. Now, if you see deployment recommendation as well, given the critical blockers identified, it is strongly recommended that deployment be blocked until these issues are addressed adequately. And then also I can see the critical blockers. No public SSH, no public RDP, no hard coded passwords, no SQL firewall open to the world. Now, if you see high or medium issues, no public blob access. And also I can see recommended fix order. Address the critical blockers P01 policy 1, 2, 5 and 6. First by implementing firewall rules, removing hard coded passwords and restricting access to private networks for SSH. Next, focus on implementing the high severity recommendation policy 3 by setting allow public access to false in your Terraform configuration. Lastly, tackle medium severity issues. Then also I can see the pull request comment here. Human review checklist. Review Terraform configuration files to ensure that all findings have been addressed correctly. This is where human technical knowledge is very, very important. If you don't know the infrastructure, if you don't know the security, then AI cannot help you here, because AI can just give you this data and also it can fix, but you are the decision maker here. That's what control, that's where let's say human control is very, very important. Test the updated infrastructure in a non-production environment before deploying it to production. This is also very, very important. Update CI/CD pipeline configuration if necessary to account for any changes made during this review. Verify that the newly deployed infrastructure is secure and compliant with relevant security standards and guidelines. Now let's look at the AI Terraform Reviewer.py. So what exactly we are doing here? We are using this policy findings.md file, and then we are building a prompt saying you are a senior DevSecOps engineer reviewing Terraform policy findings. Use only the findings below. Important rules. Do not invent resources or violations. Explain business risk clearly. Separate critical blockers from lower risk items. Recommend a fixed order. Keep humans in control of production decisions. This point is, let's say, very, very common across all the projects which we have built so far. Return the answer in this structure: AI Terraform review, executive summary, deployment recommendation, critical blockers, high or medium issues, recommended fix order, human review checklist. Then finally, we are using Ollama. I am using Ollama local model here, Mistral for example. You can use any model of your choice. If you have access to ChatGPT, Claude, Sonnet, I mean any model is fine. I am using it local model because I don't want to send my data, and also I have a GPU based computer, so I am using a local model here. Finally, we are writing all this to a file which we already saw. Then once this is done, one final step is, let's say, run the final report. So Python 3 space final report.py. This will combine the AI explanation and the scanner evidence. Press enter. Now let's look at the final PR review.md file. Executive decision summary, deployment decision, blog deployment. I can see the compliance score 49 out of 100, total findings 6, severity breakdown as well. Critical 4, high 1, medium 1. Reviewer recommendation, and also we have top fix priority. It's almost similar to what we got from our scanner findings, but we are trying to combine the Terraform review.md and also our policy findings.md and making a final PR review.md. So it might look similar, but very important point here is clearly I can see the final PR status, recommendation status saying blog deployment. Whereas now let's try to run the second one, Terraform fixed main.tf, and I'm going to run the Python 3 final report.py once again. Now let's look at the final review.md file. Here I can clearly see recommendation status approve. Now if we look at the executive decision summary, deployment decision approve, compliance score 100 out of 100. Total findings 0. Security severity breakdown, I do not see anything. Reviewer recommendation. Top fixed priority, no policy violations found. AI Terraform review, 100 out of 100. Deployment recommendation, adheres to all established policies and best practices. No critical blockers. So this looks good. This is how we are trying to generate the final PR review.md, and also I can try to approve this pull request without any issues. At this point, you might be thinking, why do we need to build a particular tool if we have something like Chekhov, TFSec, Trivi, or let's say TerraScan? You might have a question that all of this already exists. That's a very good question, I would say. These tools are, let's say, very, very excellent. In production, many teams are already using all of these tools. We also did a series using these tools on our channel. This project is not trying to replace these tools. The purpose here is to understand how AI can fit into a Terraform governance workflow. Traditional scanners answer what is wrong, right? For example, Trivi or TFSec or TerraScan can answer what exactly is wrong. But this project, what we are building, also asks, why does it matter? What should be fixed first? How can this be explained in a pull request. So if you remember the output, this is where AI is adding value to this project. These all scanners still provide evidence, but AI helps humans understands the evidence faster. Now let me show something important. AI should not approve Terraform. Also, AI should not apply Terraform, override policies, because infrastructure affects customers, revenue, security, compliance, also availability. AI should always help engineers review Terraform faster. AI should not automatically approve production changes. AI will explain evidence. Humans should make the decision. And this is the workflow that we have built. Let's summarize what we built so far. We started with Terraform code. The code looked valid. Then we applied policy checks. Scanner found the real security issues. Then AI explained us those risks. Then we generated a pull request ready report. Finally, as a human, we are going to validate before deploying. This is a realistic workflow that can be trusted in production environments. If you enjoyed this particular project, let me know what AI plus DevOps project you want to see on the channel, and also comment Terraform Reviewer so that I know that you are interested in this particular project. Also, if we have more interest, I am going to make the full source code public. Thank you for watching and see you in the next video.